I think, sir, we can wait for another 2 minutes, maybe.
Yeah, okay. I think some people are still joining.
Yeah. Yeah.
Okay, okay.
Others will join. Reading the slideshow.
So, yeah, a very good morning to everyone. This is Venkat from Genetics Coimbatore. First of all, on behalf of Genetics and Family Technology, we welcome you all to this webinar. Um, sorry. Genetics is an Indian manufacturer of automation products. So we provide products, systems, and solutions for various industries, and also we offer a didactic system for academia and technical education. We established in the year 1977, and our R&D division is approved by DSIR. We have in-house tool room facility for tool and die machining. Genetics is an integrated manufacturing system certified company. So we have a pan-India service facility. In Genetics, our 15 plus branches in India and 3 overseas offices are located in USA, Germany, and Dubai. So we have 200 plus support engineers globally and 150 plus dealers and stockists. So we have 1000 plus OEMs and 17,000 plus direct customers. So Genetics is an authorized distributor of automation studio in India. We have Mr. Madhujit Kulkarni from Pneumatic Technology to deliver the webinar today. Today, we're going to have the session on PLC. And if you have any questions related to the topic, please write in the question box and we'll sure address your questions. Now I welcome Mr. Madhujit Kulkarni to start the session.
Yes, so thank you, Sunil. So good morning, everyone. So today we will be looking at the PLC module of the Automation Studio. So before that, we will just start with the corporate presentation. So is my screen visible?
Yes, Kulkarni.
Yes. So our company, Pneumatic Technologies, consists of 130 engineers and software specialists. So we have 3 main divisions, that is in Montreal, Canada, Germany, and Pune, India. So we are an ISO 9001 2015 certified company, and we were founded in the year 1986. So the in-house expertise that we give is basically the software development, in which we have the software engineering, the database design support, Oracle, and network support. In the engineering expertise, we basically have the CAD CAM systems, hydraulics, pneumatics, automation, instrumentation training, and in industrial automation, we basically have the PLC programming, SCADA systems, electrical controls, and system maintenance. So the products that FAMIC Technologies offers is Automation Studio software, which comes in professional version, the educational edition. We also offer the AS Live Manifold and also Andon Studio, which is related to the complete optimization and design of your production systems. The objectives that we have is to have a long-term relationship with our client. We also give effective support by email or online. We have dedicated representative for each account, and we also give the support material in case you have purchased our software. So this is the milestones that we have achieved as we started in 1986. So we were just with the new SIM, the Hydro SIM. Looking at the market trends, we kept on moving ahead with respect to the times. So in 2003, we came to the product redesign CAD simulation. By the year 2009, we had introduced new modeling one-line diagram. By the year 2021, we also included the manifold workshops, improved hydraulic circuits components, and now as of 2022, we are also uh, developed a lot in terms of the didactic libraries, ladder diagram, Mitsubishi, PLCs, etc. So basically, the software is offering multi technologies and different programs. So right from hydraulics, you can see up to the different modules, pneumatics, electrical controls, OPC, ladder diagrams, workflow. So the software basically fits in different programs, right from mechatronics, aviation maintenance, electrical, up to the automotive technology. So now the key benefits is the students can use it for their theories to illustrate the different circuits covered during for the schools, even during the colleges. The teachers use it to teach the interactions. The teachers can use it to train their students. They can easily integrate the course content, and also the school eliminates the need to purchase single technology software. It can be used in conjunction with other departments. So multiple departments from the school can also use the software. So we also give the e-learning, that is remote access. So it can be accessed directly from home or school. It can create the priorities for teachers and students, configure time restrictions and access points. So basically, we also give the access to the software when you are at a remote location. So globally, our software is present in 120 countries and available in more than 11 languages. So basically used in high schools, career centers. As I said, it is used for training purposes, different colleges, universities, and also used for workforce development. That is to train the industry people for their work. So Automation Studio also makes use of different books. Like we know the basic book that we use for the hydraulics, that is Anthony Esposito. So different exercises from these books are also covered here in terms of circuits in the software. So now this is the Teachware, wherein there are different interactive exercises. There are quizzes. The students can access these quizzes and they can get their results verified, and also reports are generated. So this basically helps you to interact more with the software and also the real-time applications. So this is basically the concept of digital twin. Like we know, genetics also manufactures industrial kits. Like here you can see, we can create a same twin, that is the same replica of this in the software. You can see over here, and we can also integrate these two. So this basically is the new concept of digital twin. So there are a lot of illustrated libraries. So now once we start with the demo, we will look at the illustrated libraries. So wherein you can see the real-time applications and the components, like the conventional or the generalized purpose, the components look as if they are the real-time products. So this is what we know as, this is what we call as the illustrated libraries. So we'll just look into that once we start with this session. So we there is a benefit of virtual as well as hands-on experience. So only hardware can be provided, that is hands-on training with the equipment, and also you can integrate automation studio, that is the concept of soft PLC with your hardware. So this becomes a less expensive option because the need of the PLC is eliminated. So these are some of the manufacturers catalogs. So in automation studio we basically develop lot of catalogs. So here you can see the companies. So Eaton, Hengley, of course, our most important partner for pneumatics, that is genetics. Then we have Kogeni, Linde, SMC, UCAN. So these basically are the companies for which we have agreements and we have developed the catalogs. So these are some partial list of industrial clients. So we have different applications, that the different sectors in which we have people use our software. So for example, for aerospace, we have Airbus, Boeing, NASA. For metallurgy, say we have ArcelorMittal, China Steel. For transport, we have Denso, Honda, Harsco, etc. So this is basically the list of clients. Okay. So now we will move to the session of the PLC. Okay. So basically, this is the interface of the automation studio. On opening the software, you basically have the ribbon on the top. So we have different tabs over here. So right from the home tab, edit tab, views, simulation, tools, demo, and the teach technical training material. On the right hand side, we have basically the project explorer. So here, as you can see, you can open the particular project, save it, and close the particular project. Okay. So now on the left hand side, we have the library explorer. So here there are different modules. Okay. So right from hydraulics, pneumatics, electrical, ladder, electrotechnical, and HMI. So as of today, now we will be looking at the PLC and a small pneumatic circuit, and we will see how to link the circuits and how to see the simulation result. Okay. So now, if you remember, in the presentation, I just was talking about the illustrated libraries. So let's see what exactly that is. So in the library explorer, if you just go on the top, so here there is an open library. So if you just click on this, so here now you can see this has different illustrative components. So this is the electrical components, PLCs, renewable energy, electricity. Okay. So now, firstly, we will design a small pneumatic circuit. So for this, just click on the pneumatic illustrated library and just select this. Okay. So now you can see that here different components appear. So now we will just build our circuit using these illustrated components. Okay. So initially I will take a pneumatic source. Okay. Then I will take an FRL unit. So now you can see that these components look exactly as per the devices or the products that are available to you in real time. Okay, then I will say select a directional valve. So I will take a 3x2 solenoid spring return. Okay, then we will move to the flow lines and connections. I will just connect an exhaust quickly over here. Okay, I will establish this connection. Now I will take a single acting cylinder. Okay, so single acting cylinder with two proximity switches. Okay, so we will just rotate this. So we will just place it as per the requirement. Okay. So now we will just see that the sensors are fitted over here. So this basically is the PS2. Okay, and this basically is PS1. So we'll just see how to make use of this later. Okay, so this is PS1 and this is PS2. So these are the read switches attached. So we have just built our small circuit. Now this is the 3x2 way directional control valve. Okay, so this is solenoid operated, right? So we will build a small electrical circuit first, and we will just see how to actuate this circuit. Then we will just move to the PLC part. So now if I move to the generic components, if I just build a small electrical circuit, so we will just select a small 24-volt source. We'll select a 0 volts common. Just take a small switch. You can say name it PB1. I select a solenoid. Now here I will name it S1. Okay. Initially we will just name it S1. So this part I am doing because I just want to show you what is the concept of variable assignment and how it is to be used in PLC. Okay. So now this S1 is same as this. Only thing is we cannot directly wire it over here. So we have just kept a separate circuit over here, right? So now if I start the simulation, now if you go to the simulation tab and if I start the normal simulation, so before this S1 has been created. Now we obviously have to link it to this, right? Because this solenoid won't understand what this S1 is exactly. So we will establish a connection. So for this, if we just select on this, double click on the directional valve. So here there is a concept of variable assignment. So now this is to be linked with S1 because the name of the variable for this solenoid is S1, correct? So now here I will just say S1. So this variable that or the name that we give appears over here. So just select this and select this option which says create a read and write association. Okay. So now S1 has been linked with this particular solenoid over here. So let's see how this system works. So if you start the simulation now, so if I give the PB1, you can see that the cylinder extends, and upon releasing the PB1, the S1 de-energizes and you can see the cylinder retracting back. Okay. Now this is basically controlling this particular circuit using the electrical control. Now let's see how to make use of the actual Siemens PLC and make this particular system work. Okay, so for this, now visit the again the generic components. So here you can see that there is the Siemens PLC ladder. Okay, so if you select this particular and if you just click on the small arrow that is the list, so here you have the different products available or configured as per the Siemens PLC. Okay, so if you just select on this particular module, here you have the most frequently used components pertaining or belonging to the Siemens PLC. Okay, so now obviously we will select a rung. A rung is basically a connection module. So here you need to put the respective contacts, the logic, you will have to build it over here. So this is called as a rung. Okay, so initially we have taken a rung. Now this logic part is actually present in the PLC. Now where is the PLC? So if you remember the illustrated components library, I will again select this. Okay, so here there is the PLC illustrated components module. So if I just select this, now you can see that the illustrated PLC's module is now available. So from this, if you see, we have different companies PLCs available over here, right from Allen Bradley, Eaton to up to Siemens. So for this particular project, I will be using this Siemens PLC. Okay, so if I just select the Siemens again over here, I will select this standard diagram. So I will work with the Siemens S7 SIMATIC. Okay, so I will just drag and drop this particular Siemens module on my screen. Okay, so now you can see that this is the exact replica of Siemens SIMATIC S7 1200. Okay, so here now you can see there are different ports. Now it is very clearly given, like these are the output side ports. That is, I will be taking outputs from these ports, and the input ports are available on the top. Okay, so it is to be remembered that both the inputs and the outputs work on 24 volts. Okay, so there is also the triggering options. That is, we need basically to trigger this SIMATIC. So that will be the AC part. So that is L1 and N and the ground part. Okay, so now if you remember, we built a small electrical circuit over here. So considering the same kind of wiring connections, now we will build the electrical part to operate the PLC. Okay, so for this, if you remember, I had visited the generic components library. Again, if you visit the IC standard, okay, so now we will take the L1, that is the power supply. So now this is the AC power supply. So I will connect it to L1 over here. The for the this PLC is very easy to understand because the port names and the components have the same name, so it is very easy to connect. Okay, so here you can see the next part is N, so that stands for the neutral. So again I will connect the neutral part over here. Now there is a grounding connection, so we will just rotate this. Okay, so we have connected. Now this connections to trigger basically the PLC is done. Now to make, instead of directly connecting L1 directly, we will just insert a toggle switch over there. Say we can say start. Okay, so I'll just rotate this, and you can directly use shift and drag and drop on that line. So now the moment you give start, okay, you should see the PLC getting triggered. So let's see whether whatever we have done verifies a result or not. Correct. Now you can see that there are no lights, neither on inputs because we haven't connected, nor the outputs. But the moment I give start, let's see what happens. You can see that the run or stop command, this light basically glows because now the connections that we have done is correct. So we will be using this to trigger our PLC. Now, what is the next part? We know that we are going to use this particular PLC to drive our pneumatic component via the solenoid. Okay, so now if you remember the S1 that I used over here, now I will take it as the output over here. Okay, the S1, if you remember, we have already linked it earlier. So the same S1 now, I will make use of the PLC to trigger the S1 and to drive the actuator. Okay, so let us establish the electrical connection for the output first. So basically, I am connecting it to .0 port of the output on the output side. So here I will take a 24 volts supply. Okay, and from this port I will select it or connect it to the ground. Okay, so here we will see how this PLC will take the inputs and give the respective output to the solenoid. Okay, so we have done with the output side. So I will just remove this particular part now. So I will just remove this. Now we will establish the input connections. Okay, so initially I will select the push button. If you remember the same push button that I used over here, so I am doing the same logic over here, but only thing is now it will be fed through the PLC. Okay, so I will just quickly do that. So you can just see, so PB1. So again, now to establish the input side connections, so this M port should be connected to M. So this is the grounded part. Now, if you see, there is a L port, that is the 24-volt DC is to be connected over here. So we will just establish that connection. Now the inputs also should be 24 volts, right? So now this is to be connected over here, and this particular PB1 input will be given to my port 1. Okay, so this, if you remember the PB1 that I used over here, so this is the same. So PB1 has been connected to dot 1 port. Now what is the next thing? The PB1 has been connected to dot 1 and the output is connected to dot 0. Now how the PLC will know like how to take this input and give it to the respective output? Okay, so now for that we have to build a logic, small logic over here, correct? So now if you remember, again we go back to the ladder for Siemens PLC. So now we will make use of a normally open contact, correct? Now what is this? So this basically is the first input that the PLC will get, correct? So once you get the input over here, the output should be given back to the S1, correct? So now what is the port to which this particular input has been connected? So it is the dot 1, right? So now we will just link this variable, we will do the variable assignment for this to the dot 1 port of the PLC. So here you can see that I0.1. So just select this, say create read and write association. Now you can see that this particular contact has been linked to dot 1 port of the PLC. Okay, so now what is the next part? This has to give the output to a coil, correct? So we will take a coil. I will just name it S1 because this particular coil is the internal name for this S1. Okay, so we will just connect this over here. We will establish the connection. Now similarly, this particular S1 has been connected to dot 0 port on the output side, correct? DQA dot 0. So if you just visit this back, so now this has to be linked to dot 0, correct? Q dot 0, Q dot 1. So this is basically is the Q dot 0. So we will link it. Okay, so now both these have linked. So now let's see on giving PB1 whether our S1 works over here, and let's see whether it actuates our solenoid or no. So if I just go and start the simulation now, so I will have to trigger my PLC. So now if I give the PB1, you can see that my cylinder extends. If I release my PB1, my cylinder retracts, correct? So now we have basically made use of PLC and we are actuating our circuit. Now let us see some slight advancements in this particular circuit. Okay, so let's say suppose that there is a condition that this particular cylinder should perform only 4 cycles. Okay, once your 4 cycles are done, even if you give the input, okay, so it should not extend. Okay, so let's see now how to do that. So now since I want the number 4, so obviously there, as per the logic, what I understand is there has to be some counter, okay, to monitor or to count the 4 particular cycles. So now if you go the if you go in the counter module over here in the same ladders for Siemens PLC, so here there is a counter up. Okay, so I will just select this particular counter and place it over here. So now if we just click on this product, that is the counter. Okay, so you can see that there is a preset value. Okay, so this we will set it to 4. Okay, so there is a CV, so which will be the counting value. So this is the preset. There is a set, reset, and CVCBD. That is the accumulator value. Okay, so now initially, what is responsible to trigger this counter? So this is basically now once my cylinder activates. So if you remember here, I have the PS2. Okay, so this PS2 is my device that will sense that my cylinder has actuated. So now this has to be communicated basically firstly to the PLC. So how to do that? So again I will visit the electrical control. So here there is a normally open limit switch. Okay, so here I will just select this. Correct. So now this basically has to be linked to PS2. So we will link it to PS2. So now we have established an electrical connection between this particular read switch, that is a limit switch, and its respective sensor. Okay, so now I will select it to dot 3 port. Now once this PS2 is sensed, okay, we need to communicate the input of this particular port to the counter. So now where it is connected to dot 3 port. Okay, so now we will again take a normally open contact. Okay, so it is basically to dot 3 port. So we will quickly, I will do the variable assignment. So dot 3. Okay, so I will just move this a bit up. Now what I've done is I will be giving my input to the counter. Okay, so now this particular queue I will complete it and connect it to the second part. So now we have established the connection. To establish a reset or to reset the PLC, to reset the counter, I will say select a small push button again over here. So we'll just say put it to port number 6. I'll just take a copy and I will just name it as reset. Okay, so now to reset the counter, I have made use of RST. So again, I will quickly make use of another input. So now that is connected to the dot 6 port. Okay, so we will just quickly do the same process again. Right, so we have also made a provision to reset our counter. Correct. Now that has been done, and what is the condition that the counter should cover 4 respective operations upon the extension of the cylinder. So for this I will make use of a comparator. Now because we need to make use of some condition, right? So we'll make use of this condition. So if you see this, so this is a comparator and it will equate two values. Okay, so what is the first value is the CV value of this particular counter itself. Okay, so if we just select this particular product, so here it says iron 1 and iron 2. So these are the what is to be compared with what. So iron 1 is the CV value. So this variable now, if you see over here CV, it is basically pertaining to this particular counter itself. Okay, so that variable is present over here by default. So this we will say put it, assign it to CV. Okay, so now what is the second value of iron 2? It is 4. Okay, since I said 4 cycles, now the value of 4 is to be created in form of some variable. Okay, so for that, if you just go over here in tools and if you select variable manager, I will just say create one variable, say count 1. Okay, so what I'm doing, I'm just creating one variable over here, count 1. So now I will put a value of 4. Okay, so what I've done is I've just used a variable assigned value 4. Now I will be using this count 1 as a condition over here. So now revisit this product. So now for iron 2, you can see that the count 1, the variable that I created, is present over here. So just select this and say create a read and write association. Now iron 1 is CV, iron 2 is count 1. Okay, so this particular condition will be compared, and let us say that we need a output coil. Because we want to make use of this output now as some small condition. So I will just say break. That is, it will break my logic. Okay. Now where to put this break? Over here, because you don't want to activate your cylinder if this break condition is true. So we just make use of a break contact. So I will assign it to BRK. Correct. So now we have built the condition. We are making use of the counter to count the pulses. We have used the reset condition, and finally we are also saying that we will complete only 4 cycles. So let us see whether the ports are correct or not. So this is dot 6, this is dot 3. So dot 6 and dot 3. Okay, so now I will just start the simulation. Right, so on starting the simulation now, let us see what happens. So firstly we'll trigger the solenoid, trigger the PLC. Now if I give PB1, correct, you can see that the count value is 1 over here because I completed 1 cycle. Now again I will give PB2. You can see that count value is 2 and the same value has been stored in your comparator. Now again we will complete the 3rd cycle, and now on the 4th cycle you can see that this BRK is now activated. That is, the brake latch is now activated because this condition is true. Now even if you try to give the push button, correct, you can see that my solenoid will not activate, hence my cylinder won't extend. Now The moment I give this particular RST, remember we created the reset. So the moment I give RST, you are basically going to reset this counter. So this CV will change, it will become 0. The moment this CV becomes 0, this is the same variable. This condition becomes false. This break latch will unlatch, and again this contact will be established. Okay, so let us see. Once I give the RST, correct, now you can again complete 4 cycles, correct. So in this way, basically we have seen how to build a small pneumatic circuit. We saw the earlier electrical part, how to establish the connections to the solenoid. I removed that electrical part. I just built that same part over here. Only this time, it was the PLC that is making use of those particular connections. And we have built a small logic over here. This part is nothing but the logic present in your actual PLC in terms of the language that you use, say Allen Bradley or Siemens. So this particular thing is nothing but your logic part, which is present inside this itself. Okay, there is one way. If I just select all of this, okay, if I just go to the uh, say layer properties, okay, so here if I say a new layer, so if I just say PLC, I just created a layer. If you just select the entire part, and if you just drag and drop it in this, or you can simply, instead of putting it in a layer, you can just make it invisible. Okay, which means that there is no separate I mean there is no separate rung present in your diagram, or you can just put it in your layer. So the meaning of this is that the entire logic is basically present in your PLC itself, and the user will not, or the software, the person won't be able to see anything done separately on your project. Okay, so basically we have covered the basic how to make the connections. Now let us see some applications, or what could be the different logics that can be developed in AS to control your different real-time applications. Now, so far, if there are any questions, please feel free to post it in the chat box. Now we will see what are the different analog inputs. Now here, if you just saw that the different inputs that we received were basically Boolean, that is 0 or 1, correct? Because there was no variation. Now, does Automation Studio PLC work with analog inputs or outputs? Okay, so for this we will just see this particular exercise now. So here there is one application of controlling a small pneumatic circuit using input output PLC cards, building the logic, and basically you are trying to modulate the pressure regulator, the its setting pressure. So let us see like what exactly this particular example is. Okay, so now here you can see that there are two different diagrams basically, or if you just see over here at the top, I just made my circuit in one single diagram. Here there is a different diagram called known as the electrotechnical diagram, and this is the diagram that we basically were using. Okay, so now what this basically is, here you have the PLC cards or the input cards. These are the modules. Here I will be selecting the change in the current to vary the respective output voltage. Okay, so here across this solenoid, I will be varying my voltage from 0 to 10 when my current will go from 4 to 20 milliamperes. Okay, so the same information has been written over here. So if you remember, this is the earlier we built a similar kind of logic for our project. So here again you have the same kind of logic built, and here is a small pneumatic system. As I said, this is going to control the output side pressure, correct, on your orifice part. So let us see how this particular system works. So initially here my current is 4 mA. So now if you see that my voltage is almost zero, right, across this particular variable solenoid. Now slowly, if I start increasing my current, correct, you can see that slowly my output voltage goes on building up. And also pay attention to this part. My output regulation pressure is going to increase because I am increasing the output pressure, or I am indirectly increasing the spring setting. So here the spring setting is nothing but the actual input force given by this particular solenoid. So you can see that my output pressure goes on building up. So it will go up to 5 bars. Correct. Now the reverse operation. We are decreasing the voltage. So indirectly we are reducing the force on the regulator. Its output value goes on decreasing until it becomes zero. So here you can see that my input now is not a discrete. Earlier we saw push buttons where it is the state is either on or off, that is 0 or 1. Here it is gradual, correct. So AS PLC, Automation Studio PLC, also accepts analog inputs and also gives you analog outputs. Okay, so this is one second example that we saw how to make use of different technologies to control your pneumatics or hydraulic circuits as per your requirement. Now we will see a small example. So I will just close this project. Now there is one small example of a parking lot. You know, this particular example gives the user the idea, or students can also make use of this particular project to develop their logics, especially in schools or during colleges. So what this is, so we will just quickly see. Okay, so here you can see that this is basically a small example which gives you the, or the person who is at the security counter, the idea that how many cars might be there, or they are present, on what is the space used, or uh, is the parking free or not. So this this kind of small applications can also be done using ASPLC. So here you can see that this basically is the same PLC that we just saw, and if you remember, the same type of counter and the comparator condition has been used over here. Only difference is that this is the up and down counter together, because here the moment cars go on coming, your up counter will function, and the moment the cars go out, your down counter should come into picture. So this is a up and down counter used together. Okay, so we will just see how this particular system works. So if I start the simulation, if I enable this, now here you just have to press the car in sensor or a kind of car out sensor. So now if I just press it once, so there is one car present, say 2, 3, 4, and moment say one car leaves, so you just press this particular car out. So here we are basically making use of buttons, but this particular sensors can be fitted at your input and output gates. Okay, so if you remember, I made use of that limit switch sensor which sensed the position, correct? So likewise you can make use of the inductive sensors or the capacitive sensors, and you can feed those inputs to your PLC cards or this input side. So I will just subtract the value, correct? So this basically gives you the idea like how many cars are present. Now let's see what happens when all cars are present. So now it says lot full. So this gives the person at the security counter that my lot is full now. The moment say one car leaves, you will see that now lot is open. That means at least one space is present. Okay, so small examples like these can be created in Automation Studio. Okay, so now let us see one example of an electro-cascading PLC circuit. Okay, so I'll just close this project. So let us see what is this particular electro-pneumatic cascading. Okay, so now in this particular project, you can see that there is a hardware kit. So Genetics has developed this particular kit. Okay, so we have just put an image of this over here. So remember in the presentation we saw the concept of digital twin. So the digital twin is nothing but this same particular project or this hardware kit prepared by Genetics has been represented over here. So you can see that there are two particular cylinders. Okay, the input part, that is the Siemens or the PLC part. Okay, the input module present over here, the directional control valves, and the metering devices. Okay, so this is nothing but this particular circuit is nothing but the same digital twin of the hardware kit present over here. Okay, so let us see now how this particular circuit or this particular hardware kit developed by Genetics works. Okay, so I will just start the simulation now. Initially, if you see over here, there is this particular module which will help you to activate your pneumatic air to the circuit. Okay, so now this particular module is present over here. Okay, so you can see this particular blue part. So that is basically a kind of either the input side or the output side can be, I mean, either on or off. So it is basically a slider. Okay, so which will connect the particular pneumatic pressure or the input flow to your respective channel over here via this particular port. So now I will just slide it and just open this particular two valves, the shifter, because now the input side air is now connected to the return side of the directional valves. Now what is the next part? So I will just make use of S1 to control this circuit. So if I give S1 now, you can see that the first cycle is now performed. The first cycle is the extension of the first followed by extension of second, the retraction of second followed by retraction of the first. So we'll just do this quickly once again. So this was one cycle. To make this system continuous, so we have built another part. So the moment I give S2 now, you can see that the same cycle now will stay continuous until and unless I remove this S2 back, or until and unless this S2 switch is released. So let's see that. So now this is going to be your continuous cycle until and unless your there is a system failure, or your contact is broken, or you until unless you basically remove the S2 given over here, the system will be continuous. Now if I remove S2, it will stop. Correct. So in this way you can build the logic of your hardware kits present in your laboratory in Automation Studio. And here it is only 2 cylinders, but in Automation Studio you can even go beyond this, say cylinder sequencing of 2 followed by some drilling operation, again releasing the job on conveyor. You can make use of rotary motors to show that your job moves forward. Again, there can be cylinder operations. So in this way you can go on building the logic over here by using the PLC. Okay, so now if there are any questions, please feel free to post it. I think there are some questions, so we will just address it quickly. I think K. Rohit had asked one question like, how can we generate pulse width module? I think PWM signal from PLC, and can we directly give it to solenoid coil? No, I think this type of PWM signal cannot be directly taken from this. But if this PLC is actually the replica of the soft PLC, if you have if for example if you collect the output from one port, you can say feed it to your actual the PWM, and then in the field you can connect it as per the application, because this particular PLC will directly give you respective voltages in 12 volts or 24 volts format. Okay, so I think there is one second question, how to connect load, example 5 kg with the cylinder. Yeah, okay, so that can be done. So now I will just go back to my project over there, which I had initially created. Okay, so now if you visit this particular generic components library, okay, if you go to the pneumatic module, suppose you have a double acting cylinder over here. Now I will just rotate it so that it will give you a feel. But this particular rotation is not, it doesn't mean that your cylinder becomes vertical. It is just rotated. So if you just double click on the cylinder here, if you go in the data, okay, so you can see that we are measuring the angle with respect to the variable known as alpha. Okay, so the inclination here, if you set it to 90°, okay, now your cylinder is vertical. Now there is a mobile mass And also if you see over here, there is an external load M. Okay, so if I just say 5 over here, so it means that the mass present on, I mean the mass is now present over here, which is having a value of 5. So if you just connect a source and try to verify the result, you will see that the load, that is 5 into G, okay, so that weight divided by the piston area will be the pressure required to lift this particular cylinder, so that you can verify from the simulation. Okay, so I think, yeah, that was one question. So coming to the last part of this particular session, I will just show you one webinar. Sorry, I will just present you one video wherein you will understand how actually the the laboratory device or the trainer. Okay, so if you see, this is the genetics pneumatics kit built by genetics. Okay, so here if you see, the same type of kit that we saw in the exercise earlier is being controlled by a laptop. Okay, so the PLC is not the one present over here, but it is present within the laptop itself or your computer. So let's see now what happens.
Kulkarni, sir?
Yeah, hello. Yes.
Yes, sir. This is Venkat here. The audio is
Yes.
very low, sir. Can you please raise the audio of the video?
I think, sir, I mean, are you able to hear this basically?
Slightly, sir.
Okay, we'll try to increase the. No, I think this is full from my side.
I think you have to increase the system audio, sir. Okay, sir. No problem. We'll proceed with the video.
Okay, I think because I just wanted to, show the users like how to establish the connection.
Connection is made in the automation studio. The pneumatic circuit.
So you can see that the same kind of circuit we built and the ladder logic. So here they are making use of the pneumatic cards. Okay, so there the read sensors are used over here, and the PLC logic is not present in the PLC module fitted on top of the trainer, but this itself is your PLC now.
With the end position sensor, then IO card assembly, that is PLC input and output model, and the field devices, whatever we have called in the logic, and the below is the PLC radar logic. So these three things are integrated in the circuit. When we try to operate this, the cylinder will forward, and as soon as it reaches the end position, it will retract automatically back to the position. The same thing we are going to see in physical conditions. In CNC, there is no program available.
Now what this person is saying is that in this particular PLC there is no program. Okay, only thing, the program built in AS has been fed to the this particular PLC. Okay.
It's simulated in real time with physical. So I'm going to show you push button, then I'm pressing go. So as soon as it reaches the manual sensor, it retracts back to its original position. Since it is in auto mode, now the cylinder piston rod moves forward and reverse in automatic.
Now you can see that this particular cylinder has a continuous extension and retraction. Why? Because he's saying that this particular logic, the same extension retraction principle that we saw in the trainer kit earlier, our example, the same kind of logic has been done only for this particular cylinder. So let us see.
being simulated in automation studio.
Okay, so here you can see that he has basically configured a continuous extension and retraction for this particular cylinder. Now, since this particular logic has been conveyed via OPC to the Siemens PLC, so that particular trainer kit will also undergo the same continuous extension and retraction. Okay.
And the real-time feedback also we are getting it through OPC communication.
Correct. So in this way, basically you can actually now connect this particular logic if you have, and if I have built that kind of logic over here, if you connect this particular logic via OPC to the actual trainer kit in your library, so whatever logic we have built over here, the same will be seen on your trainer kit, or it will work as per the logic that we built in PLC. Okay, so I think this is all from my side. So thank you. So yes, Sunil sir, you can go ahead.
Yeah, thank you, Madhujit sir. So finally, we are at the end of this webinar series. Hope everyone had a great journey. If you have any queries related to our products or requirement, please visit us at genetics.com, and you can send us a mail to inquiry@genetics.co.in. We thank the entire farming team and Mr. Madhujit Kulkarni for the session today. Thank you, everyone. Have a great day.